Transferable hard coating is a technology where we have a piece of mylar film with a hard coating coated on one side of the film. Now the film, or the coating itself, has unsaturated sites. So when the film is placed in the mold in contact with the BMC or SMC compounds, during the exothermic process, the unsaturated sites on the hard coating will transfer onto the cured substrate, thus allowing the hard coating to become part of the part. To give you a quick demonstration or idea, what we have here is a piece of the film that was, or a plaque that was molded with the film in mold, and I have removed the film. And you can tell by the high gloss areas where the hard coating is, and this is the uncured portions. And what we'll do is give you a quick idea. What I'm using is a 4/0, or no, it's a 3/0 steel wheel, and you can tell by the scratches on the uncured or the untreated part versus the hard-coated part that your abrasion resistance is improved dramatically. Now, the purpose of the purpose of the hard coating itself is to protect the part, but also increase the weatherability. Now, the next generation of that part of the film transferable hard coating is where we took a piece of the film with the coating and printed an image onto the coating. And what we're trying to do is transfer that image onto the cured substrate. And you can tell from here, we transferred the image, and we're protecting the image with the cured with the hard coating on top of the printed image. Now, what we'll do next is we're going to end up showing you how to use this film in the mold so you can utilize it in your process. The idea of this product is to allow you to cure and transfer images and protect those images on your substrate all in one step in the mold. The film transferable hard coating has been utilized with SMC, BMC, pultrusion, and also different types of resins other than just unsaturated polyesters. It's been transferred onto acrylic, polycarbonate, and some polypropylene type resin systems. Okay, we'll come on over here and we'll show you how it works. Now, what we're going to plan on doing is placing the film and the BMC compound in the mold and pressing it out. Now, the film does have some limitations. The film is just a means of transferring the hard-coated image onto the cured substrate. So you can only do one-dimensional or two-dimensional type part. So flat and corners can work, but if you try a three-dimensional, you'll get wrinkles in the film, which will transfer onto the cured substrate. Another thing in terms of utilizing the film is air entrapment. We want to make sure the film is in the bottom part of the mold, thus when it's pressed out, all the air can be released. If we leave the film on top and press out, any off gases and any air will be trapped by the film, and those bubbles will prevent any contact between the hard coating and the cured substrate, and then you won't have a finished cured transfer onto the substrate. So what we're going to do, we'll place the film into the mold, like such, place our BMC compound on top, and get ready to press it out. Now, we're going to be molding at 300 degrees Fahrenheit for about a minute and a half to 2 minutes. During that exothermic reaction, the hard coating will transfer to the unsaturated sites to the BMC compound. The image will transfer with it and become part of the part, with the hard coating resting on top of the image, thus protecting the image and the plaque itself. This allows in-mold coating but also transferring in-mold images to create a higher value part during the molding process, all in one step. So for customers that are looking for specialty type images in architectural settings, indoors or outdoors, they can have a graffiti protected, a scratch resistant protected, and a weatherable hard coating protecting those images on their cured substrate. Okay, we just finished pressing out our mold. Okay. Now what we have here is the plaque with the film and the image. Now what we're going to do is we're going to peel off the film, leaving the image and the hard coat protecting that image behind. Again, the film is just a means of transferring the image and the hard coating, but I'll pull this off here. There we go. As you can see here, we're leaving the hard coat and the finished image on the substrate, and the film, again, is just a means for transferring it. Now, the idea is to have a higher value, or make a higher value product in mold from beginning to end. I've shown you just a basic piece of the film that we've placed into the tool or the mold for pressing out, and you've seen some of the plaques of the finished images that we've pressed out within the mold. Okay, but I wanted to give you an idea of the actual film itself. Again, we have a Mylar with the hard coating, and what we did is we, on a flatbed printer, we printed out the images on a roll-to-roll. So the only real limitation is how much ink you have in the printer. You can print as many images, any different type of image within onto the film, and what we were doing is we were just cutting out the small pieces and placing them into the mold. But basically what you can do is you could have a roll-to-roll process where you advance the film into the mold, place your BMC compound, press it out, and then advance to the next, and then place your BMC compound and press out, and then advance to the next. It can be done in a mass production type process with a roll-to-roll type process.